Hi guys, today we're going to go ahead and finish up Chapter 7, Section 4. This is our section on function operations and compositions of functions. So just as a review, the first day we did what's called function operations. The cool thing was we were able to take two functions and using an operation such as addition, subtraction, multiplication, or division, we were able to combine those two functions to form a new function. Then yesterday, we looked at something called compositions of functions. A composition means you can actually take one function and fill it into the other function, and then once you are done simplifying, getting rid of those parentheses, combining like terms, you have a brand new function. Now today, we're going to take it a step further, and we're going to be able to evaluate compositions of functions. So evaluate means that at the end, rather than having a new function, you're actually going to have a number. Now this is really fun, okay? We're just gonna go ahead and jump into the examples because I think that makes more sense to actually see it, okay? When you're dealing with math, remember you always do what's inside of the parentheses first. So if I'm looking at A, inside the parentheses, it's saying take the g function and replace the x's with a 2. So g of 2 means I take the g function, which is 5 times x, but instead of x, I plug in a 2. Well, 5 times 2 is 10. So g of 2 is really equal to 10. So now I can go ahead and write 10 in the place of g of 2. So now I have the f function, but where there's the x, put in a 10. The f function is right here. So instead of x, I put in a 10. Now it's order of operations. You would do your exponent before you add. 10 squared, 10 times 10 is 100, plus 3. 100 plus 3 is 103, and that is your answer. So super fun. You're just evaluating functions for a given variable. You just have to do it twice because it's a composition. Always do whatever one is in the parentheses first. So this means take the f function, change the x to a 1. So in the f function, again, I'll just remind you what that is. Here's what the f function is. It is x squared plus 3. If I am doing f of 1, what that means is I just have to replace the x's with a 1, because in the notation, that's what we did. We replaced the x with a 1. Order of operations. 1 squared is 1. 1 plus 3 is 4. So f of 1, what's on the inside, is actually 4. So now I can write it as g of 4. So now I go to the g function, and I replace the x with a 4. So it's 5 times 4 equals 20. Done. One more with these functions. Inside parentheses first, take the f function, replace the x with a negative 2. So negative 2 squared plus 3. Remember, if you square a negative, you will end up with a positive because negative times a negative is a positive. Negative 2 times negative 2 is positive 4. 4 plus 3 is 7. So now I can go f of, instead of f of negative 2, we know that that's a 7. So I can take that 7 and write it in the place of f of negative 2. So now my new directions say f of 7. So I take the f function again. Where the x is, I put in a 7. 7 squared is 49. 49 plus 3 is 52. So there are 3 examples using f of x as x squared plus 3 and g of x as 5x. So now we're going to go ahead and do another set of 3 just for good measure to make sure that it makes sense. This time, when they tell us to use f of x, we are using 5x plus 1. When they have us use g of x is 3x squared. Again, you always do what's in the parentheses first. So the first thing that I am calculating is g of negative 1. So I take the g function. Where there's an x, I put in a negative 1. Now here's where it's important that you know your order of operations. We have multiplications and exponents. Exponents always come first. So 3 times negative 1 squared. Negative 1 times negative 1 is a positive 1. 3 times 1 is 3. That's what g of negative 1 is. So now I have f of, instead of g of negative 1, you replace it with its value, which is a 3. So now I take the f function, 5, but instead of x, I put in a 3. So 5 times 3 plus 1. 5 times 3 is 15. 15 plus 1 is 16. And that 16 would be your final answer. Let's look at 2 more. Start in parentheses. Take the f function, replace the variable with the 0. So 5 times 0 plus 1. 5 times 0 is 0. 0 plus 1 is 1. So now I have g of, instead of f of 0, I put in its value, which is a 1. So I go ahead and I take the g function. Where x is, I plug in a 1. Exponents first. 1 squared is 1. So this is 3 times 1, which is a 3. Last one, and then I will let you go about your day. In parentheses, you take the f function, put in a 3. So 5 times 3 plus 1. 5 times 3 is 15. 15 plus 1 is 16. That's the value of the inside. So now I have to go ahead and plug that 16 into the f function. So it's 5 times 16 plus 1. You multiply before you add. 5 times 16 is 80. 80 plus 1 is 81. So guys, that is it for the third part of Chapter 7, Section 4. Today you have just a few book questions where you can practice this on your own. And then tomorrow is a worksheet kind of tying all of the ideas from 7.4 all together. And you guys, then we made it through a whole nother week of distance learning. I hope you're doing well, and I will talk to you soon. Take care.